Hello friends and welcome to EdupediaWorld.com, your destination to online education. Friends, as far we are continuing with the sessions of the gradation of physical properties. So today we shall discuss the conduction and also learn the variation of conduction property in periodic table with respect to groups and periods. So let's start first with the concept of the conduction. So what is conduction? Well, conduction is the transfer of energy in the form of heat or electricity from one atom to another by the direct contact. Well, it occurs when temperature increases, the molecules start vibrating, and this vibration and movement pass the heat energy to the surrounding molecules. Or you can say that the vibration of free electrons, that is a valence electron, and this vibration occurs with a rapid movement which gives rise to the electrical conductivity. So let's understand these types of conduction. We have two types of conduction, conduction of heat and conduction of electricity. Let's understand now the property of conduction with respect to the elements. We know that we have two types of conduction, that is a thermal, we also call heat, and electrical conductivity, that is electricity. Now we know that if we talk about the elements, we have metals, metalloids, and non-metals. We know that metals are the good conductor of thermal and electrical conductivity. Metalloids are the semiconductors, and non-metals are bad conductors, whether it is a thermal or electrical. So firstly, let's understand the heat conductivity, or say the thermal conductivity. Well, you might have observed that a frying pan becomes hot when we kept on the flame. It is because the heat passes from the flame to the utensil, and when the pan is removed from the fire, it slowly cools down. Why does it cool down? The heat is transferred from the pan to the surroundings. So you can understand that in both cases the heat flows from hotter object to the colder. Heat flows from hotter to colder. Well, this process by which heat is transferred from the hotter end to the colder end of an object or an element is known as conduction of heat, that is thermal conductivity. To check this concept, let's take an example. Take a beaker, put it on the flame with the water in it, put some objects like some metallic pan of cooking has a plastic or wooden handles. You can put some metal spoon, pencil, scale, or any article you can dip into like that, like divider also you can keep. So what happens, the material which allow heat to pass through them easily are the conductors of heat. Like this will give a conduction that will get hotter, the divider will be get hotter. Pencil and scale, which are of wooden and plastic, will not get heated up easily. So these kind of materials or objects, we call them the insulators. For example, aluminum, iron, and copper are the good conductors of heat. These are the elements which are good conductor of heat and electricity both. And if we talk about the insulator, that is a poor conductors, we can say that the non-metals and such as plastic or wooden materials can be bad conductor of heat and electricity. So the second concept is, we said that about the heat conductivity, that is thermal conductivity. Let's talk about the electrical conductivity. Well, what is electrical conductivity, friends? Electrical conductivity is nothing but a movement of electrically charged particles through a transmission medium. Like we have said earlier, metals are the good conductors, non-metals are the bad conductors, electrical conductors. So let's take in a reason why we say metals are good conductors of heat and electricity. Let's talk about the heat. Why are the heat conductive elements? Well, in metals, the force of attraction between the particles is very strong. First, the forces of attraction between the particles are very strong. So the particles are tightly packed together. This allows easy and fast flow of heat energy through the metal objects. It should be noted, friends, that air and water are the poor conductors of heat. So, friends, this is the reason why metals are said to be the good conductors of heat, just because they have the molecules or the particles of the metals have are very tightly packed, and the force of attraction between that is called the intermolecular force between the particles are very strong. So the flow of heat is very easy. The electricity, why we say that metals are good conductors of electricity, just because the metals have the free electrons, that is the valence electrons, which are closely bonded to the atom. So they have free valence electrons which actually acts as charged carriers in metallic structure, which allows the electric current to flow through the metal objects. So these are the two basic reasons why we call the metals are good conductor of heat and electricity. Now let's talk about the non-metals. First we talk about the heat. Why we say non-metals are bad conductor of heat, or why we say that they are bad conductors of heat and electricity. So most of non-metals have covalent structure. First of all, they have a covalent structure. So these structures basically does not allow heat energy to travel from one point to another. Doesn't allow the heat to travel from one point to another. As in metals, the heat energy quickly travels from the point to another due to the vibration of free electrons in the electronic bond screening and the metal ions. Well, in non-metals, the electrons are bound inside the atom, so cannot help the transfer of heat energy. The second point we can write that the electrons are bound inside the atom, which actually does not help the transfer of heat. Let's talk about now the electricity conductivity. Well, the electrons in non-metals have very fewer free electrons and are held tightly that they do not allow the movement freely. The free electrons are fewer. They don't allow the movement freely. Well, friends, let's understand by this, as the non-metal have the covalent bonds, which are actually very strong. So they don't allow the non-metal to pass heat or electricity through them. So these are the some basic reason why metals are the good conductors and non-metals are the bad conductors of thermal and electrical conductivities. So here we conclude we have metals with free electrons to pass electricity. We have the structure of metal allow the heat to pass through them, whereas in non-metals no free electrons. Well, they have free electrons, but they are much fewer free electrons and are very tightly packed to each other. They are not allowed to move freely, so they cannot conduct electricity. Doesn't allow free movement. And the bonding, that is a covalent bond, which does not allow the heat pass through them. That is from one point to another, that is one particle to another. They don't allow. Now let's talk about the variation of conductance in periodic table. Well, in thermal conduction, when we talk about the period, the thermal and heat or heat conduction decreases as we move from left to right. Well, in groups, the thermal conductivity in a group increases when we move from top to bottom in a group as the metallic character increases in a group. Also, the electrical conductivity, as in the periods, when we move from left to right, the conductivity of the element first increases, then decreases. And in group, it generally increases as the metallic character increases, but we have some exceptions also. For example, if we talk about the periods, why it happens. For example, let's talk about the third period, where the sodium, magnesium and aluminum are all metals and they have the metallic bonding, in which positive metals ion are attached to delocalize the electrons, and these electrons are freely to move and carry charges. So so when we go from sodium to aluminum, the conductivity of the element increases. Why? Just because the number of electrons increases and there are more electrons which can move and carry charge. So the electrical conductivity increases. And from the silicon, which is the metalloids, and has a giant covalent bonding, and this giant lattice structure similar to that of diamond, in which each silicon atom is covalently bonded to 4 other silicon atoms in a tetrahedral arrangement, which you will be learning the details in your future classes, future sections, or you can see the higher standards. So in which Each silicon atom is covalently bonded to four other silicon atoms with the tetrahedral arrangement, and this extended in the three-dimensional to form a structure. So it is called a semiconductor. So friends, then it keeps on decreasing just because we move towards the non-metal. As in phosphorus, sulfur, and chlorine, the outer electrons are not free to move and carry charge because they are held strongly in the covalent bond. And in argon, which exists in a single atom, the outer electrons are not freely to move and carry charge because they are held strongly in the stable third energy level. So now let's conclude. In the periodic table, when we move into the period, that is when we move from left to right, the electrical conductivity first increase, then decrease, and the thermal conductivity similarly. You can say it basically thermal conductivity also depends upon the element, but generally it decreases when we move from left to right. And we talk about the groups. When we move from top to bottom, generally the conductivity, that is the electrical and thermal conductivity, increases as the metallic character increases. But yes, we have certain exceptions also, by which the general trend does not allow all the group to follow these trends. So I end up with the session, and the next session we shall learn about the density of the elements, and also we shall learn about the variation of density of the element in the periodic table with respect on groups and periods. Thank you for watching Edupedia World videos.